Okay, here's some examples from solving polynomial equations, and these are a little bit more challenging because we have more zeros than 2, so we can't use the quadratic equation. If we have a quadratic, 2 zeros, then it's easy to use the quadratic equation. But in this particular example, 2x cubed minus 5x squared minus 11x minus 4 equals 0. The number of zeros we have is equal to, and this is from the fundamental theorem of algebra, it's equal to the highest degree of any variable we have. So since we have x to the third, that's the highest degree, we have 3 zeros. And we can solve a quadratic equation for 2 zeros by using either the formula or completing the square or factoring, but with 3 zeros with a third power, it's a little, we can't do it like that. So we have to find one of the zeros. So hopefully one will be a rational root, so we're going to check our possible rational roots, and those are going to be the possible factors, and we just have to look at the factors, I should say, for the possible roots. The factors of the constant term, which would be 4 or plus or minus 4, all over the factors of 2, which is plus or minus 2. So I should just say 4. And the factors of 4, we can see, are going to be what? 1, plus or minus 1, plus or minus 2, plus or minus 4. And over the factors of 2, which would be plus or minus 1, plus or minus 2. So we can check our possible factors over here. So we've got over 1, we could have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, and then we can go over 2, plus or minus 1 over 2, plus or minus 2 over 2, and plus or minus 4 over 2. Now, this is going to be just plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/2. But 2 over 2 is 1, so I've already got that, so that's a redundancy. And then 4 over 2 is 2, and I've already got that, so that's a redundancy. So those are my possible rational roots, 2, 4, 6, 8 of those. And I've got to check each of these using synthetic division to see if I can get a 0. So let's get to work. So first of all, I'll try 1. And we'll write our coefficients up here. 2, minus 5, minus 11, minus 4, and then we'll just apply the process of synthetic division to see if this 1 goes in. Bring down my 2. 1 times 2 is 2. That's a negative 3. 1 times negative 3 is negative 3. That's a negative. When we add, that's a negative 14. 1 times negative 14 is negative 14. And then when I add this, I get negative 18. So that's not going to work. That's not a 0. So let's try negative 1. That's our next possibility. And we got 2, negative 5, negative 11, and negative 4. Bring down the 2. Negative 1 times 2 is negative 2. And we add the negative 5 and negative 2, we get negative 7. Negative times a negative is positive, so that's positive 7. Negative 11 plus 7 is negative 4. A negative times a negative is positive 4. And there we go, we got a 0. So one of my roots is going to be negative 1. Now we could have a repeated root, we could have negative 1 again. Now 1 won't work, so 1's out. But we could have a possibility of a repeated root there. But let's go on and check what we've got here, because now if we look at our reduced equation, remember my initial power was 3. So when I divide one root out, I have 1 less power, so it's going to be 2. So this is going to be 2x squared minus 7x minus 4 equals 0. And now we've got a quadratic equation, and we can either factor it, complete the square, use the quadratic formula. I don't really want to go to the trouble of factoring this. There's a way to do that, but just in case, I'm just going to use the quadratic formula. Remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, so that's your quadratic formula. So we'll just say x equals, and we'll just substitute in minus b plus or minus the square root of b squared minus 4ac all over 2a. And let's put our values in. Oops, 2a, what was a? I should say 2 times, I don't know what a is, so substitute that in, excuse me. Now we've already got one root, and this is going to help us find the other 2 roots, because we have three roots, because our original equation was to the 3rd power. So we reduced it to a square, and we can use the quadratic formula. And what was b? B was -7, so I'll put a -7 there. What was a? A was 2. This is b here, this is -7, I'm sorry, b squared, -7 squared. A was 2. C was -4, and that was all times 2a. So we should have 2a here. So this should be 2 times, and a was 2. There we go. Okay, now let's just work that out. And that's not too bad. X equals, a negative times a negative is positive, so I got 7 plus or minus. The square root, -7 squared is 49. A negative times a negative is a positive. 4 times 4 is 8 times 2 is, 4 times 4 is 16, pardon me, not 8. 4 times 2 is 8. 8 times 4 is 32, so there we go. That's where I got that. All over 2 times 2 is 4. So x equals 7 plus or minus the square root, and 49 plus 31, that's 51, 60, 71, 81. All over 4. And that's going to end up being 7 plus or minus 9 all over 4. So those are my possibilities. So I can do that over here. So x equals 7 plus 9 over 4, which is 16 over 4, which is 4. Or x equals 7 minus 9 over 4, which is -2 over 4, which is -1/2, and those are my 3 roots. 4, -1/2, and -1. So those are your 3 zeros. Okay, we can write those over here. The zeros are -1, 4, and -1/2. So that's all there is to that. So you can take a look at this, take a look at it slowly. It's not too difficult. You just have to do the synthetic division. Okay, hope that helps.